Hello everyone. In this lecture, we will be discussing the formation of Ybus using singular transformation method. So first of all, you see this network. In the previous lecture also this network we have discussed. So in this network, this is a IEEE 4-bus network. So in that, 3 are generator bus, 1 generator. So this is a generator and we have converted into the voltage source to current source conversion. I complete this. So in this, what we will be doing in the singular transformation method, that means it is based on the graph theory, based on singular transformation method based on graph theory. So the method, so-called method, is known as the singular transformation method. So this method is basically the graph theory method, based on the graph theory. So as you know, I think you have all the knowledge on the directed graph. So from this graph, how will get a directed graph? So directed graph means there will be the direction except the sources, active sources, passive sources. So with the element you can draw the graph. Okay, now see here, this presenting the impedance. This is also 9 impedance. This is presenting, but this one is source and this one is impedance. Now see how it is presenting. So this one is one branch with the direction is not depending in the, it should be in the downward. Okay, direction in this 1 to 2, it may be in this way also. Whatever the direction, you have to maintain firstly the direction should be there. In the directed graph, direction should be there. Okay, so what I did, I take any arbitrary direction. So for this 1 to 2, this is taken 1 to 2 and this way, there arrow in this way, arrow in this way, arrow in this way, and this way. Okay, so after giving direction, what you have to do, we have to put the bus voltages. So because this voltage is bus V1, V2, V3, V4, as we did in the last lecture also for the direct inspection method. So for this also, what we do, what we will be doing for each and every branch. So this branch, this branch, this branch. How many branches in this network? Directed graph for this network and admittance for that particular branch. Okay, so I am naming it as a this. Suppose this is one IA current is flowing through this branch. YA is admittance of this branch, and VA is the what voltage of this branch. Okay, bus branch voltage, and for this I am considering VB, YB and IB. Okay, this is the branch only. Okay, not injection current. Okay, not branch voltage. Sorry, bus voltage. So this is we are dealing with only branch, not bus या injection current. Okay, so for this also IC, VC and YC admittance for a particular impedance element would be there. So for that element we are getting the branch admittance, branch current and branch voltage. Now we are interested in each and every branch voltage, current and the admittance. Okay, so and for this we are considering B, C, D. Suppose this V, D, I, D and Y, D. Okay, A, B, C, D. Suppose we are considering this E, D, D and Y, E. Okay, for this let's consider for this E, F, I, F, D, F and Y, F. Suppose A, B, C, D, E and one more, this one. So suppose this one is this it is F. Suppose this I, G, 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 and for this G, H, I, H, D, H and Y, H. Okay, with this what we can get, we get for each and every branch we can form one equation. Okay, suppose current I1 for first A branch, what we can do, so EA and YA we can write. For IB what we could write, D. So EB, Y, D, like that. BC, YB, sorry, YC, BC, EB, Y, ED, AD, YD. Means for each and every branch in that way we get F, sorry, was H, I, H, H and Y, H. So last thing was number of 1, 2, 3, 4, 5, 6, 7, 8. 8 number of branches. There are 8 number of branches. So we'll get the 8 number of equation. Okay. So from this equation what we could get? We could get on matrix. This is IA, IB, IC, ID, IE, F, G and IH. This equation we will get. And correspondingly what we could get, YA, YB, 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 H. And this one matrix A, F, A, B, C, D, E, F, H. A, B, C. So this matrix will get. So in only here what from this equation, this 8 equation, what we form here, we take a one matrix form. So this called is this current, the primitive current matrix. So called this matrix is primitive matrix. This called is a Y prime matrix. Y means admittance primitive primitive matrix, and this one called the B primitive. This primitive means you can consider as a primitive means trans. Okay. So from the equation what we could get, the I primitive, the branch current, Y primitive, the branch admittance, and Y primitive, E primitive means this admittance. So these are the equation. Okay. So from this equation what the others, these are only the diagonal element. Okay. Others elements are 0. Okay. You fill this 0, all the elements, only diagonal elements will be present. So what would be the matrix size? So for this case 8 by 8. Okay. And other elements are only the diagonal element present for this. Okay. So for this case what will be getting? I primitive and the Y primitive matrix and E primitive. So this equation we can simply write. Okay. So this is equation which is given. Okay. So if it is always true. Okay. So I primitive, E primitive, and Y primitive and E primitive. Okay. Now what we can see. So suppose this is the network. Okay. Now what we could put, we will be trying to establish some relationship with bus voltage and the bus voltage and branch voltage. Okay. So what we could get? Firstly we will check the bus voltage for this. So bus voltage V1. Okay. So V1 is nothing but we can present A. So okay, right. So VA is equal. Okay. Now VB is V1 minus V2. VC what? VC is V2. VCD B2 minus B4, I guess. This one B, and E B1 B3 B1 B, and for this what F G, G means B1 B4 1 B4 G H B3 minus B. Again this set of equation we got 8 equation we got. Okay, so from there what we put from, so here B1 B E A E F G H. So this we can get this equation, this one. So what is this primary? Now what we can get in terms of, suppose in terms of you have to find the voltages. This matrix is there. Suppose you are interested to find in terms of V1, V2, bus voltages. Okay. Now what we could get for first equation VA. So what, this one is 1 and remaining are 1, 2, 0. Space 1, 0, 0, 0. Okay. So the first element, okay, for BA, other element are 0. So for BB 1 minus 1. So for B, this 1, this is minus 1. Okay, for BC, what we could get, the V2 only. This BC got BB, B2, B4. BB, what we could get, B2, B4. This one. And for BE, what we could get, BE 1 minus 3. 1 minus 3, 0. E, F, only V3 is present there. So for H, F, it is like this, EG 1 minus 3, 1 minus 3, 1 minus 3, 1 minus 3, and for last one E3 minus 4. So this is the matrix. Okay. So this matrix, what do we know? This matrix is called the incidence. Incidence matrix. So we can present this matrix as a. Okay. So this matrix is like this. Now suppose in the first matrix what we got, the I primitive, Y primitive and E primitive. Okay. So with this what we could get, if it is B primitive, so we can replace this as matrix. So if it is A matrix and it is Ybus, so what we could put ultimately from this I primitive is Y primitive. So if it is Y primitive, now in place of E primitive what we could put, the matrix A, what we just considered. This is the incidence matrix of a particular network. Okay, and this is the bus. Okay, now we are interested to get an equation of injection current, because as we know that the admittance, that means the admittance matrix, when we will get for a network the current injection in respect of the voltage bus. Okay, so now it is available, voltage bus is available, but here the current is primitive current, that means branch current. So we should be interested in now the injection current. Okay, so injection current, what would be the injection current for that network? So is IA, IB, this is IH, IA, IB, and HIE. So this one equation. Okay, and for I2 what would we get? I2 there would be IC, IC minus IB, IB plus just like that, because this I2 is going to be this and I2. Yes, this is I2, and for I3 what we could get, I3 will be this branch, this I F minus IE minus IH. So this is 3, and for I4 what we could get I1, I2, I3, I4 minus I3 minus I8 minus I is B. So this is my equation. So from this equation what we could form? So the I1, I2, I4. This is also represent a matrix in terms of IA, A, B, C, D, A, D, H. Okay. So here what would be for there would be the 1, 2, 3, 4, 5, 6, 7, 8. What would be the dimension of this matrix? The 4, 8, the 4 by 8. Okay, 4 by 8. So this one, this one, this one, this one. 4, 5, 3, this is the element. So what we could get? A, B, C, and A, B, A, C. A, B, C, D, E, F, G, H. Okay. So for first equation A, B, H, H, it is not C, it is E. E. So it would be positive. 1 A, B, A, B, E, H. Okay. That means it is H. It was G. It was G, sorry. It was H. It is G. Others are 0. If others are 0 and I1, I2, IC and ID positive and IB is negative. IC, ID, IC, ID positive, but IB negative. It's negative. 0, 0, 0, 0. Okay. For I2 is 1. For I3, for I3, IF, IE, IH, IE, IH minus IE, IS minus IF positive. Okay. For I4, GHD all negative. GHD, GHD all negative are 0. Okay. So you can see the comparison with this matrix value of 0, 1. So this is also one matrix in 0, 1 form. In before also we got one matrix, this matrix. Okay. So for this matrix and this matrix, what we could get? The similarity. So this matrix we can create as a transpose of that. If you find the transpose of that matrix, you will get definitely this one. Okay. So if that matrix is known as A, so this would be the transpose of that matrix. So we can name it as the A transpose. So simply we can see that this is current injection matrix for the network, where we will get the A transpose and the equation of what? I primitive. Okay, I primitive. So I injection, A transpose and I primitive. So this is also one equation you should remember. Okay, now so where we left that equation is I primitive, Y primitive, A and Ybus. Okay, now simply if you multiply with A transpose matrix, we are multiplying with this I primitive equal to the A transpose of Y primitive A and plus. Clear? So if it is so like that, so now if we see this matrix, so this overall matrix, and this matrix, ultimately what we could put this matrix would be the I injection. If it is I injection and with this bus matrix, okay, so overall this matrix would be presenting as a Y bus matrix. This is bus. So as we know this, the relationship between for Y bus matrix, admittance bus matrix, so this is the injection current, this whatever the matrix would be, and this is the bus current. If you create some relationship with this between the injection current and bus voltage, so this matrix, this obviously so called matrix is the Y bus matrix. Okay, so the Y bus will be presenting simply what? Firstly you have to find the incidence matrix, then Y primitive matrix, and this would be the transpose of the incidence matrix, and this is the Y primitive matrix. Okay, so far what we discussed, so in the singular transformation method you have to firstly find one the directed graph for any particular network. If you find the directed graph, and then you go for the incidence matrix. Okay, incidence matrix what? The bus voltages and relate to the branch voltages. Okay, from there we'll get what? One equation we got, the first I primitive, that means branch current, branch voltage, and admittance Y primitive. Okay, so I primitive, Y primitive, and B primitive. So this equation we got one. Secondly, what we got? Secondly, we got the B primitive and the admittance incidence matrix with the Ybus. So this equation we got. Okay, the thirdly what we got? Thirdly we got the current injection with the relation with A transpose, that means incidence matrix transpose of the I primitive. So this equation we got. Okay, these three equations we deal. Okay, so remember these three equations. Okay, and one more thing for the B primitive. What? For the B primitive means Y primitive matrix. So Y primitive matrix, so whatever the number of branches is available to form the directed graph, so that number of elements would be present in the matrix. Okay, in diagonal way, and the non-diagonal all elements would be 0 for the simple case. Okay, so later case also we'll discuss whenever the mutual coupling will available in some transmission line, in between two transmission line, if there are mutual coupling, so their effect will come. Okay, we'll discuss later lecture. So this is ultimately the single transformation method. So with this I will give one problem also, so try to solve this, that in this way. Okay, firstly you form the primitive matrix, then you firstly form the incidence matrix or the voltage related to the branch voltage related to the bus voltage. Okay, so that incidence matrix we form first, and the primitive matrix, and first and forehand, firstly we have to do the naming of the branches A, B, C, D, E, whatever the number of branches available. So you name it firstly. In that sequence you have to do. Otherwise there will be element will not get the proper element. Okay. And with this, whatever the singular transformation way you will get the result. Okay. You just compare with the previous one. What you have done using the direct inspection method. Okay. So this is up to the singular transformation method. Okay. And with this I am signing off. Thank you. God bless you.